In this lesson, we'll talk about how to find relative extrema, and we can do that. We're going to do that using the first derivative test. So to understand the concepts, let's look at these graphs. And this is a relative minimum. There's a relative minimum. Relative minimum. This does not have a minimum. So let's look at these relative minima here. And so let's look at what do they all have in common, because we need to be able to find relative extrema without looking at a graph. We're going to use characteristics of the function and the first derivative test to determine if there is a relative extrema or relative minimum. So this point is a relative minimum, and this point has an undefined derivative, and this derivative is 0. So what's happening, we need to find out what they both have in common, including this one. Here's an undefined derivative also at this point. So we look at that and we say that the slope is negative and then the slope is positive. The function is decreasing and then the function is increasing. Here the function is decreasing and then increasing. The function is decreasing and then increasing, and we're going to look for that using the derivative and the sign of the derivative. The derivative is negative, and then the derivative is positive. The derivative is negative to positive, negative to positive. And we're going to look at critical numbers, which we saw in the last lesson. And a critical number is where the function has a slope of 0 or an undefined slope. And we're going to look at those critical numbers and then see if the slope goes from negative to positive, the derivative goes from negative to positive. That will give us a relative minimum, and then the maximum will be when the slope goes from positive to negative. Here's a maximum positive slope, negative slope. First derivative is positive, first derivative is negative, and that's the first derivative test. Is the slope changing from positive to negative? If it is, then that's going to be a maximum. If the slope changes from negative to positive, then that's a minimum. So before we talk about extrema, let's just talk about increasing and decreasing. Well, I guess we are going to find the relative extrema, but we're also going to talk about increase and decrease. Because it's important that we know this vocabulary, because there are questions they don't ask you about extrema, but they just talk about increasing and decreasing. If a question asks you to find the intervals of increase and decrease, we have all the same steps as if we were finding the relative extrema. So let's find the critical numbers. Find the first derivative, and we want to know when the first derivative is 0 and when the first derivative is undefined. These will be the critical numbers. When is the first derivative equal to 0? It's at 1/2. A polynomial, that's a polynomial. It's never undefined. And let's organize this test, the first derivative test, by looking at a number line. And we have a critical number, and then we're going to test numbers on either side to see what the slope is on either side of the critical number. So we want to have f prime of 0. What do we get if we put a 0 in here? We'll get a positive number. And then over here, f prime of 1. If you put a 1 right there, we'll have a negative 1. So we see the slope at 0 is positive. The function is increasing. And then the slope at 1 is negative. So now the function's decreasing. And we can see that at the critical number, there's a relative maximum. And then we have to talk about increase and decrease. So we say f of x is increasing all right. If we said this and then we said that there's a relative maximum when x equals 1/2, that would be a complete answer. But if we haven't said this yet, when we say what the relative maximum is, we have to say f of x has a relative maximum at 1/2. Alright, so here's a complete answer, and on the AP test we can't just show this and then say this. We also have to say this because f prime changes from positive to negative or something like that. Alright, do the same type of problem. Find the intervals of increase, decrease, and relative extrema for this problem. Pause the video. Alright, critical numbers. We have two critical numbers. Let's test them to see which one is a max and which one is a min. We can pick any number on either side, and we need to find y prime of -3. Let's put -3 into y prime, and make sure you remember that when we did absolute extrema, we used the original function. We wanted y values of the function. Today, we want to have y values of the derivative. So if we put a -3 right here, it's going to be positive 9, 27. 27 minus 12 is positive. We don't need the value, we just need the sign. And then if we put a 2 in here, no, if we put a 0 here, 3 times 0 minus 12, that's negative. So we'd say y prime of 0 is less than 0. It's negative. If we substitute a 3, that's the same as if it was a -3 because we square it, and that's going to be positive. Y prime of 3 is positive. So we know that slope is positive, and that means the function's increasing. The slope is negative, so the function is decreasing. The function is positive, so the function is increasing. And we can say that the function is increasing on the interval negative infinity to negative 2 union 2 to infinity. The function is decreasing from negative 2 to 2. The function has a relative maximum at x equals negative 2 because y prime changes from positive to negative. The function has a relative minimum at x equals positive 2 because y prime changes, it's a weird word, changes from negative to positive. Alright, and with the trig, let's go through this one together. Same question, find intervals of increase, decrease, and relative extrema. Let's find the critical numbers. That's when we look at the derivative. Here it's cosine, and we want to find out when f prime is 0 and f prime is undefined. Cosine equals 0. We want to find out when x is 0 and the radius is 1. If we look at the graph, x is 0 means we'll be on the y-axis, and the radius is 1. So these angles are where cosine is 0, and we get pi over 2, 3 pi over 2. Cosine is never undefined. So we have pi over 2 is a critical number, and 3 pi over 2 is a critical number. We need to check numbers in between. So let's check 0 and pi and 2 pi. And we need to find the slope at 0. So f prime of 0 means we put a 0 in here, and cosine of 0 is 1. So we know that we get a positive slope there. If we put pi, we get cosine of pi is a negative, and 2 pi, cosine of 2 pi is a positive. So we have the graph is increasing when the slope is positive, it's decreasing when the slope is negative, increasing when the slope is positive. So we say that f of x is increasing on the intervals, and let's write 3 pi over 2, it'll go up to 5 pi over 2, and then it's increasing from negative pi over 2 to pi over 2. We know that cosine goes on, oscillates forever, so we have all these repeated intervals. So f of x is increasing on these intervals, and then we can say f of x is decreasing on the intervals here pi over 2 to 3 pi over 2. And let's go to 5 pi over 2. We can just put it over here. 5 pi over 2 to 7 pi over 2. Decreasing. And then we can say f of x has relative maxima at pi over 2, 5 pi over 2, and then we would say because f prime changes from, if it has a maximum, changes from positive to negative, f of x has relative minima at negative pi over 2, 3 pi over 2, repeated, because f prime changes from negative to positive. Alright, and we'll stop there.